Good afternoon. Welcome to today's webinar, The 3 Leading Causes of Pedestrian Railway Accidents. During this webinar, our presenter will cover the following: pedestrian accidents involving commuter rails, subways, and freight rails, trespassing, falls and platforms, sidewalks, and crossovers. Today's webinar features transportation and traffic engineering expert Carl Berkowitz. Carl has 46 years of transportation and traffic experience. His areas of expertise include accident studies, slips, trips, and falls, pedestrian accidents, perception reaction capabilities, subway and commuter rail accidents, speed and distance analysis, and railroad grade crossings. If you have a question that pertains to the presentation, Carl and I have asked that you submit them using either the chat or the Q&A feature, which are found on the right-hand side of the screen. Carl will do his best to answer the questions as they come in during the presentation. We will be taking a formal question and answer break approximately halfway through the presentation. Tomorrow morning, I will send out an email with a link to the archived recording of this webinar, and I do ask that you take time to fill out the survey that will appear on your screen after the webinar is over. I now invite you to sit back, relax, and enjoy. I'm going to turn it over to our distinguished presenter, Carl Berkowitz. Carl, it is all yours.
Thank you very much, Matt. And let us begin. The 3 topics that Matt just mentioned that I'm going to discuss are right-of-way trespassing, falling from a station platform, sidewalk crossings, and crossover pathways. And this is, as an introduction, it's not unreasonable for anyone who's using a transportation facility to expect that the pedestrian environment is going to be safe. And most of the mishaps that occur in this environment are the result of unexpected design changes. And sudden changes in design can offer the opportunity for something to go wrong. And what we need is in design to have obvious visual cues, depth cues, and other mechanisms which we can attract the person's attention. The first level of preventing any kind of railroad accident is removing the hazard in the first place. There are numerous pedestrian standards and best practices, but number one is the standards that were developed by as a result of the American Disabilities Act back in 1990. And those standards can be found with the U.S. Access Board, and they have numerous standards, and they're available from them, from the U.S. Department of Transportation, and many organizations in the United States provide these standards. There are many standards and codes in addition to the American Disabilities Act, and you have to understand with a standard that this is a result of a consensus of a group of people that get together and vote on that standard. I serve on several standard committees, and we vote, and majority rules. And it's not always possible to have every situation covered by a standard. And what is important to do, in addition to the standard and codes, is in any situation is to have a risk assessment to determine the level of risk and how you can comply to that level of risk and what is acceptable. The primary standards and codes are those organizations that are listed here, the American Association of State Highway and Transportation Officials, which has several publications, one of which is called Geometric Design of Highway and Streets, the Institute of Transportation Engineers, which has numerous publications on safe walking, the American National Standards Institute, which has developed standards for safe walking as well, the American Public Transit Association, which has several handbooks, guidelines, and standards to enable one to design a safe railroad environment. The American Railway Engineering and Maintenance of Way Association is the professional organization where most of the engineering guidelines and standards have been developed that are used in the transportation industry. And I previously mentioned the U.S. Access Board, the U.S. Department of Transportation through the Federal Railroad Administration, better known as FRA, and the Federal Transit Administration have a number of standards which will help and guide to safe operations of a transportation railroad facility. There are also some codes which are promulgated by the railroads, and one is the NORAC, which is the Northeast Operating Rules Advisory Committee, which has certain standards and guidelines that pertain to the design and to the performance and conduct of their employees. A second one, which is also covers mostly the Midwest and the south of the United States and the Southwest, is called the General Code of Operating Rules and Committee, and it's generally abbreviated GCORC, and NORAC is NORAC. In addition to that, the Public Service Commissions or the Commerce Commissions of the states have promulgated standards and guidelines to protect pedestrians in the railroad environment. Three publications that you might want to own a copy of. The first one is the Manual of Uniform Traffic Control Devices, which provides traffic control guidance for the railroad environment where streets or sidewalks or pathways cross through the railroad environment. A second publication, the first one, there's a cost, but the second one is free, and this one's from the Federal Highway Administration, and this handbook provides information in terms of designing highway railroad crossings and guidelines and standards to make them safe for pedestrians. And a third standard is the Manual for Railway Engineering, and this is quite a hefty standard guidelines. It's 4,000 pages, and you have to have a lot of bookshelf space available to make this available. And this provides a lot of information on engineering, design, construction of railway and its facilities, such as stations. We read in the papers quite a bit about fatalities. Most railroad accidents result in fatalities when there's a collision between a pedestrian and a train. 99 out of 100 times the train wins. And some of the headlines that have recently appeared are these that are listed here. A man near the west end of the platform jumps in front of a train. A woman apparently walked in front of an eastbound train. 16-year-old girl was trespassing on the tracks. Train strikes cyclists who cross tracks in front of train. Unfortunately, all of these listed accidents resulted in a fatality. Just to give you some of the statistics from the Federal Railroad Administration, between 2007 and July of 2010, there were 1,638 pedestrian rail trespass fatalities. This is just people trespassing onto the right-of-way of the railroad, with California leading the way, and you can see the difference between California and Georgia. California being an awfully big state, but there are other states like New York, which is awfully big, but the number of fatalities is significantly less. Pedestrian rail trespassing casualties, these are the ones that result in death. There was approximately 3,000 rail trespass and injuries in the period between 2007 and 2010. And the casualties alone were a significant portion. At railroad pedestrian crossings, there were many less accidents than on the right-of-way, but still a significant number of accidents. There were 484 pedestrian rail accidents between 2007 and 2010, July of this year, and you can see that there seemed to be a decline, and now again there seems to be an increase in the number of accidents. From the same period between 2000 and 2010, there has been a slight increase in the number of accidents. A lot of the problems in terms of why we have accidents is the time it takes a train to stop. The distance the train travels before or after hitting a pedestrian, this information can be calculated, and it relates to the train braking, deceleration, and the reaction time of the train operator. The elements that are involved in this, the train being able to stop, involves a multi-step process, and that is when first the pedestrian is observed, path of the train, and then the pedestrian is actually seen, and the operator sees the pedestrian in his path. There's a complete detection, and he understands what's going to happen, and the operator recognizes that there's a probable chance of an accident between himself and the pedestrian, and he begins to take action, or she begins to take action, and what the action is the operator moves to prepare to brake. And this action is completed, and the braking process, the emergency braking process takes place. The time to react, and that's the step 1 through 4, generally takes about 1 second. Unfortunately, there aren't a lot of studies out there that involve this process. The last studies that were done in the United States, believe it or not, were back in the 1970s. There have been many, though, studies done in the laboratories which were independent of whether it was a train operator or a machine operator or a truck operator. These studies that have been done in the laboratory by human factor experts, psychologists, psychiatrists, have looked at this perception reaction time. And most of these studies still come back to approximately 1 second. Of course, there are other circumstances which might come into play, which might affect the size of the perception reaction time. Even if we have an efficient perception reaction time, this does not guarantee that a correct decision will automatically follow. There's always a possibility that individuals who perceive and react will make the wrong decision. A failure or delay in any of these perception reaction time steps that we previously discussed, you can see will result in a tragedy. Some of the areas that will affect the lack of the perception reaction time are things such as lack of experience, unfamiliarity with the equipment, misinterpretation of information, and errors in visual performance, fatigue, and many other situations. Reaction time basically is how fast can one detect an occurrence and initiate a response. No matter what tasks we as individuals take on, every activity we take on requires time. Existing information and reaction time, as I mentioned before, is based on laboratory experiments, simulation studies, mathematical theories, and field observations. A lot of work has been done in this area in Europe and the United Kingdom, but lately, in the last 40 years, not much work has been done in this area in the United States in terms of train operator simulation studies and field observations. Train operator has a lot of responsibility, and the operator has to focus primarily on the right-of-way ahead and look for pedestrians, vehicle crossings, and activities on station platforms. The observing of the right-of-way, he needs to observe the track ahead, determine if there are any obstructions or incursions onto the right-of-way. Not only pedestrians, but vehicles, debris, fallen trees, all sorts of possibilities of obstructions on the right-of-way. And he's always also looking, or she is always looking for an expected event expectation, making, well, that event that is unexpected and could happen, and one never knows when and where it will happen. Train operators operate in a predictable and lawful manner, and they can always be able to respond to an unexpected event. They work long, hard days. They try to focus their attention, and they, of course, have limited cognitive resources available to them, and they can't concentrate on too many things at once. And also, it depends upon this operator, and safety depends upon the training of the operator, what his or her expertise are. And of course, memory depends both on what actually happens and how one makes sense of what has actually happened. And a lot of the after studies of accidents, we find that it's sort of like a Rashomon experience. As many people as you ask and that's as many explanations of the experience that you're going to obtain. The best way of knowing exactly what happened is when we have a video recording. And accident reports, of course, right after the accident is a practical way of keeping a good and accurate record of what took place. One of the things we talk about in perception and reaction time is the concept of applied attention. How many tasks can any individual do at one time? How rapid can the train operator switch from one task to another? How widely can the train operator deploy his attention across the many things that are available for him to observe in his visual field? Train operators' attention control depends upon ability to monitor multiple information sources over an extended period of time, to learn how to allocate resources by shifting his or her attention over relatively important activities that are taking place in their visual area. Even when all this is taking place and we're well tuned, it is also important to prepare for the unexpected, infrequent, or high priority event. And this can only be achieved by doing simulation tests, doing simulation training, and practicing one's craft. The train operator in their daily duties is interpreting information, recognizing situations, making important decisions, overseeing the operation of the train, and any conditions that could degrade the ability of these tasks could serve as an antecedent to an error which ultimately results in an accident. Antecedents can increase reaction time, interfere with the cognition of the train operator, and limit the train operator's ability in many other ways. Impaired when the quality of performance is below that which is necessary to function safely. And there are many possibilities that can intercede into the daily operation of a train operator. Some of those are lack of attention leading to a mental lapse, inability to see or hear a specific feature, inadequate or incorrect knowledge for a task, a deliberate violation, breach of rules or procedures, procedural errors, using wrong procedures in a given situation, an unintended action from a slip or a lapse, and of course tiredness or fatigue can influence behavior as well. One thing to keep in mind that trains move very fast and are generally operating at their maximum speed. And most passenger rail lines are Class 4 rail lines, and the train can operate, if it's a passenger train, at 80 miles per hour, and if it's a freight train, at 60 miles per hour. And it takes a good long time to stop when it's operating at that level of speed. The total stopping distance is the distance traveled for the train between the time a pedestrian is detected and when the emergency brakes are applied, and the stopping distance is the distance required to bring the train to a full stop from the time the person is observed, the pedestrian is observed, until the train comes to a full stop. It is when the train operator applies the brakes, and when the train operator is interviewed, it is not uncommon for the train operator to state to the interviewer that the train was placed into emergency braking the moment the pedestrian was observed in his visual area. And we know this is impossible because before the train operator could put the train into emergency braking, there's this intervening perception and reaction time that could be 1 second, or it could even be more. And the various elements that come into play in the distance and time traveled, of course, is the velocity of the train, its acceleration rate, is it going at a constant velocity, what's the braking, emergency braking characteristics of the train, and what rate is the train braking, and the velocity and the related braking deceleration. And that all comes into play in terms of what is the final location of the train after emergency braking is put into effect. Just as an example, if a train is traveling at 10 miles an hour, in 1 second it will travel 15 feet. And in 3 seconds it will travel 44 feet. And if you're going 80 miles an hour, you can see how many feet the train travels in 1 second. If the train is put into emergency braking, now this is for example, subway cars in New York City Transit. This will be different for freight trains, significantly different for freight trains, and also different for large commuter trains and other types of trains which have different braking characteristics. But you can see that the number of feet, if the train is going 10 miles an hour, how many feet it takes in an emergency application to stop the train. And that's all, and the difference between the emergency application and the full service application, as you can see, is 50% at 10 miles an hour. And that's with an empty car. When the car is fully loaded, it's handling a higher load. That increases the emergency braking by 50% and the full service braking by 25%. There was an interesting accident, not very interesting for the people that were involved in it, but in Spain recently there was a train that delivered beachgoers to the beach, and in order to go to the beach there were two ways of going, one a safe way and one that was not so safe, and unfortunately these young individuals took the unsafe way because it was poorly marked. And what they did is they went through a rail tunnel of an act that the trains, the commuter trains and the intercity trains serving this beach. And unfortunately for these young people, 13 were killed in the tunnel and an additional 14 were seriously injured. And this is all because there was improper information provided to these young people as once they got off the train, what was the best way for them to get to the beach. Another thing that I find very interesting and disturbing is if you go on the internet and you plug in walking on the tracks, you find many pictures of children walking on the tracks, and this is not a very good example. In fact, this Bride magazine shows a bride and a groom walking on the tracks, and you have here pictures of kids walking on tracks. In fact, even one child laying across the tracks. This is not one way of setting a good example for children, which are the primary individuals that are injured in trespassing accidents on the tracks. Some of the factors that affect this decision to walking on the track are such things as the distance and access to desired locations. Children are walking on the tracks because the tracks provide the best opportunity to go from point A to point B. And for some children, it's the only way they can get from one place to another because they live in a community where walking is the only alternative to traveling. They're too young to drive, there's no public transportation, and the railroads go to the best places. And the railroads provide disconnections to many important crossing points between points that children want to go to, including going to school. So the railroad tracks become a necessity for them to get from where they are to where they want to go. And they get a false sense of safety because in many places the trains travel so infrequently that the children become complacent that the trains will never show up and never appear in their environment. And many times they use the tracks with no concern. And here you have an example of what the children do. They break the fence to gain access because it provides convenience and connectivity. There are no sidewalks in the communities they live in generally, and other topographic barriers prevent them from going from one place to the other, such as roadways that are disconnected and have to go, in many cases, long distances to cover the same distance that you can cover in a short distance on the tracks. And then there's the concept of playing chickie, where kids go on, I may be using a term that may date me, but peer pressure has a big factor in children going onto the tracks and trespassing onto the right-of-way. In order for the right-of-way to be safe for the children, it's important to have clarity. They need to know exactly where the right-of-way is and understand the information about the danger, visibility. There needs to be access control of the right-of-way, which would be clearly visible and illuminated. We need to eliminate access, perimeter fencing, fences between the tracks, preventing the children from crossing the tracks, providing alternate paths for them, have physical treatments along the right-of-way to make it safe and inaccessible, and barriers and continual information system, security systems where we have lighting, which would contribute to making the right-of-way secure and guide children away, compatibility, where we have access control, which is designed to be compatible with the community and the adjoining properties. And I mentioned fencing before. That's very important. Fencing not only along the right-of-way, but between the tracks to deter access. Excuse me. Detectable warning, alerting youngsters of the dangers of trains approaching. Alternate path markings, guiding them on a safe way to go from point A to B. Significant signing, passive and active control, and something that is new and is being tested. And this is intrusive control, which uses cameras and intelligent transportation systems. The intrusion detection systems are being applied at crossings and along the right-of-way. And if we had the resources and the money that is required, this system would be applied everywhere along the right-of-way and at all crossings to make them safe for pedestrians and for vehicles. This is an example of this vehicle detection system using cameras, and this was taken at the nighttime. And these are kids about to cross railroad right-of-way across a bridge where there is limited clearance. So if they're on the bridge and the train is coming, either they jump off the bridge or they have the possibility of being struck. And here we see a student crossing the right-of-way and another one using the right-of-way for their bicycle path. Not too wise. Do we want to stop now for some questions, Matt?
Yeah, I think that would be good. I have said that we can use the chat or Q&A feature on the right-hand side to submit your questions. So we do have a couple questions here already for you, Carl. There is one that asks, are there guidelines for preventing railroad right-of-way trespassing?
Yes, there are. There are the handbook that I showed you from the FHWA has some suggestions. There are guidelines that are produced by the American Public Transit Association. The Federal Railroad Administration is doing research at their research center in Boston to come up with intrusion prevention systems, and they're being applied on a limited basis. Hopefully, as the technology becomes more and more practical, we will see this included all over. And the technology is no different than if you had a home intrusion system to prevent a burglar from entering your house. It's not too different from that type of system.
Okay, great. We have another question here that asks, why is the train operator reaction time important? Well,
the time, the interesting thing, and I'm going to discuss it later on in the presentation a little bit more, but a pedestrian, is if they have enough information and they are warned sufficiently, they can easily get out of the right-of-way of the train. It's the difference between a fatality and a safe excursion away from the right-of-way is a fraction of a second. So if the faster that a train operator can react and respond, the better chance that the pedestrian has of surviving a collision, and a better chance of and a good chance of avoiding the collision.
And we also have a follow-up to that. In the age of cell phones and smartphones and iPads and iPods, are you finding that in your work, train operator distraction is becoming a very big issue?
They could be summarily fired if they use any of those instruments. It's against the operating rules of NORAC and the other organizations and the federal government and the local governments and all the operating authorities. If an operator is caught using any of those instruments, unless it's using the phone for an emergency purpose, they can be summarily fired and with no recourse. The other thing that's happening is individuals are dropping their iPads, their iPhones, their cell phones onto the railroad tracks and doing a very stupid thing and going down and trying to retrieve them. And a young person has been severely injured and killed as a result of trying to retrieve their instruments, their electronic instruments. I hope that answers that question.
Oh yeah, definitely. No, thank you. I think it's a very big issue. I don't see any more questions in the queue. For all in attendance, if you do have a question from Carl, you can submit them throughout the presentation, and he'll do his best to answer them. We will be taking another formal question break at the conclusion of the presentation of content.
I see we have one from an old friend, Colin Falk.
Sure, go for it.
Most safety measures, active warning devices, not paid by the railroads. Why has the railroad not stepped up and accepted that responsibility? Well, basically, the crossings are paid for in most cases by the federal government. But some of the commuter railroads are also paying for the installation, like the Long Island Railroad out by my area. They're paying for, and not always being fully reimbursed, paying for and reimbursing and maintaining. But the Federal Railroad Administration is the primary source of funding for railroad crossings. And why they
Okay, great, and thank you for submitting that question to Carl. I don't see any more questions, so why don't we continue on with the presentation, Carl?
Okay, thank you. This is some of the signage that is out there, and you can see that some of these signs are not going to be very attractive, and you can see that young people are not going to pay much attention to these signs. Some of them are so old that they're hard to read, and some of them are not clear enough that they fully understand. And sometimes these signs do not really draw the attention of the young people and are generally ignored. And here you see examples of inter-track fencing. The top two pictures show inter-track fencing. The middle two pictures show right-of-way fencing, and the lower pictures also show right-of-way fencing. And these are some ways, and these fences need to be maintained because young people have figured out how to remove the fence from the fence structure just by disconnecting or cutting a couple of snips of wire that are holding the fence in place. One of the really good programs out there, and every state is participating in this program, and that's what we call Operation LIFESAVER. And they're making a big effort of educating kids in the schools. They have various materials, and they run what they call their 3 E's program: education, enforcement, and engineering. And they provide a lot of guidance to local governments and to railroads on enforcement and engineering, and do a very good job in terms of providing the education that is necessary in the schools. And in New York State, this has proved to be very, very effective in reducing fatal injuries and less than fatal injuries of individuals in the right-of-way. This is some of the material that's out there, and despite this material being out there, you can see, and these are actual pictures of individuals going actually in front of the trains. You can see a young lady taking a stroller in front of a train that's operating at a very slow speed and not being very cognizant of this train. And one of the things that people that are interviewed after accidents, they say, well, it looked to me that the train was so far away that I had plenty of time to get out of the way of the train. If you've ever been in an airport and if you looked up and you see an airplane flying, it looks like that airplane is not moving at all. And there's this optical illusion when a train is coming to you that it's not moving at all, and it could be moving at 70, 80 miles an hour. And that's why some of these accidents do occur. And we have to find a way of keeping people off bridges. I have a bridge near where I live, and the high school kids constantly use the bridge as a shortcut from the high school to their community. And they feel that the trains hardly come. Our service here is about once every hour, and they take a big risk because there is no place to step aside on that bridge when that train is coming through. Matt, I see we have somebody asking a question. Are trespassing signs a sufficient replacement to fencing in areas of known trespassing? Do train operators have any specific duty to keep speed of trains at a certain level at known places of trespassing? Unfortunately, signs don't do a good job. They are just a minor deterrent. Young people tend to ignore signs. Most studies show that they completely ignore the signs. They feel that if people wanted to keep them off, that they would have taken a more positive approach, such as building fencing. The train operators are never given any warnings. There are speed signs that are posted on the right-of-way for the train operator, and that basically is for conditions of the track and not for trespassing on the trains, on the train tracks. The train operators, even though there should be some caution, tend to operate at the allowed speed, and that is that speed if it's a Class 4 railroad and it's a passenger railroad, it's 80 miles an hour. If it's a freight railroad, it's 60 miles an hour. And there should be, where there is intrusion into the right-of-way, there should be railroad speed postings and notifications to the train operator that they should reduce their speed at those locations. This is not always happening. I hope that answers that question. We see a lot of passengers on tracks, and this is happening more and more. And some of the reasons why passengers are ending up on the tracks are medical, accidentally falling, suicide attempts, being pushed by crowds on the platform, and as I mentioned earlier, to retrieve their electronic device, school books, backpacks, and we have these unfortunate experiences. If you look at the last picture of a young lady who let go of her stroller, and the platform was slightly pitched towards the tracks, and the young child and the stroller ended up on the tracks. And thank God for the train operator, they were able to stop in time, and there was no injury to that young child. In Japan, the first level of suicide is the first choice of suicide in Japan was to jump in front of trains. So the Japanese have added these platform walls, these 5-foot platform walls along the entire platform, and added doors like elevated doors to prevent access to the station. But I guess if somebody wanted to commit suicide, they just climb over the wall anyway. And some of the reasons that we have falls from platforms is that we have poor design of the platform, poor maintenance, uneven walking surfaces, changes in elevation, loss of balance by individuals, whether it be medical or the design of the platform, expansion joints that run along the platform that sometimes cause a tripping hazard, and overcrowding on the platform. We have another question that was asked by Vivian. Where does the railroad obligation for safety end, and where does the adjacent landowners begin? That's a good question. Rarely do we find landowners, other than installing privacy fences, putting up fences along the right-of-way. You would think that the obligation would be the railroads because it's their right-of-way, and in most cases the railroad was present long before there was land use activities adjoining the railroad. This is a good question, and this may be addressed in some of the Public Service Commission rules and regulations in the individual states. Some of the factors in crowding are the physical layout of the platform, obstructions, location of stairs, escalators, ramps, and elevators, time of a passenger arrivals, and when you have too many trains arriving at the platform at the same time, and passengers arriving and trains being delayed, and all this passenger accumulation on the platform, and no one making an effort to keep people off the platform, we have this overcrowding situation which can be very dangerous, and in many cases passengers have been pushed because of the crowding on the platform onto the tracks. And there are some other possibilities of crowding factors. Again, pedestrians, unlike motor vehicles yield to pedestrians, and at crosswalks and crossovers, trains are never required to yield. They have the right of way, and unless for some other reason that there is something imposed upon the train, such as a light rail train or a trolley that operates on a public street, where there are red lights that will control the movement of the train. But in all other cases, the train doesn't have to yield. It's the pedestrian in the vehicle that has to yield. And unfortunately, every time a pedestrian is struck by a train, the result is a fatality. And as I mentioned before, pedestrians are less restricted and they are able to control their movements more so than a motor vehicle, and if properly warned, are able to get out of the way of a train. So warning is very, very important. And the way to protect the pedestrian is by having safety by design. We have to use many techniques that a pedestrian will look for the train. And this is a critical element in designing for pedestrian circulation in a railroad environment. Here are samples of crossways, and you can see that the pedestrians are guided in crossing, that they can only cross at the crossways. And there are federal highway standards that recommend a minimum of 5 feet of space on these crossings to allow two people to pass to pass comfortably or to walk side by side, so that you can have at least 3 people operating on these crosswalks, and in some cases even more. But you notice the channelization and control that is being applied here. Some of the safe rail crossing attributes is to have an awareness, the ability to see the approaching train on the part of the pedestrian, clarity. It should be obvious where the crossing is, and easy to understand and easy to use. These seem like common sense things, but are not always being applied. Visibility, the location, and the illumination of the crossing to allow the train operator and the crossing persons crossing to be able to see each other. This is important. Sometimes these crossings are obscured, even though there is no reason to be, the result of vegetation, trees that are blocking the view of the pedestrian, and maybe not the view of the train operator, who may be sitting higher up and may have an opportunity of seeing. So we need the clearest visibility at the crossing. We need a continuous path. It shouldn't be non-continuous to make it safe for the pedestrian to cross. There should be frequent crossings so that pedestrians are not opting to cross at an illegal location because the crossings are so far apart. Pedestrians should be able to move quickly across, and there should be frequent opportunities to make that crossing. The physical treatment of the crossing is important. We saw from those previous pictures that the crossing is safe and convenient, and there is good lighting and placement to make it safer for the pedestrians. It should be easily accessible, and it should always meet the ADA requirements, even if it is not an ADA crossing, that the station has not been designated as a accessibility crossing. Can't go wrong if you follow the ADA. Safe crossing design, the crossing material should be durable. It should be compatible with other crossing materials. It should be smooth. The width should be adequate for 2 people crossing and able to pass a third. The surface should be level and flush with the tracks. The pathway should be familiar. They should be very familiar. They should know where it is. There should be no problem, and there should be no problem in terms of information and guidance as to using the crossing. And a person who is not familiar should be able to use it, and that every crossing should use and follow the national standards such as the ADA, so no matter where a person is, they should have no problem using that crossing. The most effective non-visual information is information that is easily located, visible in any weather, and it should be intuitive to understand. You shouldn't have to have a college degree and a master's to understand the information. When you interview people with disabilities, you always find they always stress the importance of consistency in providing information. So if we provide the consistency that the disabled require, everyone else will have no problem using that facility. Good design is critically important, and some of those things, of course, if we think about our parents or people, young people or elderly and impaired, and we design with them in mind, we should have a facility that's good in design. And when we place non-visual information, and it has to be considered that many pedestrians are going to be unfamiliar with that environment, and the information we place should be understood by the youngest person that would be using the facility who is able to read, and of course the oldest person. Some of the things that are applied to make the environment safe on a platform especially is edge markings, which provide a well-defined pathway along the approaches to the crossing and direct the pedestrians to the right clearly defined crossing point. And the three areas of control that are used: signage, signs to warn or direct; passive controls, which provide static messages of warning; and active controls, which provide advance notice to the approaching train. These are all very important, and these are fully delineated in the FHWA guidelines and the MTUCD guidelines as well. This is a sample of a crossing, and you notice that they ensure that the crossing and the track, the railroad track flange are flush with each other, and they use this neoprene, this rubber material, rather than asphalt to reduce the changes in level and to eliminate the maintenance problems at the flange of the track. These are some examples of controls that are used to keep pedestrians from crossing the tracks at inappropriate times at an official railroad crossing. And these are gates are used, as well as gates and fencing and also guidance. As you can see, there's sort of a maze guidance in this location. These are some examples of flush crossings, and you can see the intermediate gates in two examples, and how a person with a wheelchair or with a stroller will have no difficulty crossing the track safely. And I mentioned earlier that sight distance is very important, that we have to bear in mind the speed of the train, and that people entering the crossing area will have ample time to observe. And you can see at a train operating at 80 miles an hour, a pedestrian needs almost 1,400 feet to observe the train and to cross safely. Let's go back a little bit to the pedestrian information needs. Pedestrian information needs are very important. This provides the type of information that can be rapidly assimilated, and also such things as detectable warning. Those are those yellow tiles with little bulbous raised circles, and this is called the tactile warning strip. And these are very important information systems to guide and assist pedestrian crossing. A pedestrian must obtain all the information they need to safely cross, and that's what good information should provide. And the information should be observed at critical junctures at the crossovers, entrances, and exits. Pedestrians who are visually impaired have also learned based on cues, and if you don't provide them with basic cues, they cannot make those crossings safely. Information must be in multiple formats and redundant, and announcements, and every possible technique should be employed. And of course, as I mentioned, the manual of uniform traffic control devices provides a lot of guidance on signs and signals. And these are some of the warning signs that you will find in this manual. And these are the emergency notification signs. That's in case the emergency notification sign is in case something is not operating and you want to report an emergency. And regulatory signs, and also pedestrian crossing signals. These are flashing lights and bells to alert pedestrians about trains coming. One of the problems that have been confronted, where you have two tracks, and pedestrian sees the train stopped in the station in one direction and doesn't look in the other direction for a train coming in the other direction. Many railroad companies do not allow two trains to enter the station area at the same time because of the concern that pedestrians won't be looking in both directions. This is a sign advising pedestrians to look in both directions because trains are operating in two directions. There is a hierarchy of controls. The first hierarchy to make the environment safe for pedestrians is remove the hazard through the design process. And if the hazard is existing after the facility design and you're coming back, then let's remove the hazard in a redesign process. And let's get those engineering controls in place. Let's have automatic and manual warning systems, and let's have continual inspections and training of the personnel to ensure that the system is always operating in a safe manner at all times. And one of the things that should be done all the time, and that should be done on a frequent basis because things change over time, and the hazard analysis looks at the safety process and allows the railroad to evaluate hazards and find various ways and methods of solving those problems. The purpose of the hazard analysis is to identify the safety hazard and their causes, determine the hazard severities and probabilities, and recommend corrective actions, and provide documentation evidence of compliance with codes, design standards, safety requirements to management, so that everyone knows that the corrections have been made and implemented. Some of the things in hazard prevention, is determining what are the root causes of that accident. And this involves the search of those factors that cause the problem, the accident in the first place. What is and by looking at available data, the nature of these causes can be determined, and we can also find out what are some of the undesired consequences that are causing the causation to the accident. Then we conduct an accident investigation, and the safety practices of the property will help us in avoiding future accidents. We will be able to inspect and be able to determine what are the defects, and the inspections will help us lead us to a design and construction to eliminate and in the future have written procedures so these problems don't occur in the first place. And tracking accidents. One of the things, and this is very easy today because the Federal Railroad Administration maintains a tracking base where you can look at any intersection and find out what is the history of that accidents at that location. Of course, those are only accidents that have been reported. And then having a safety program put in place. And the preventive measures, as I've been mentioning time and again, are passive and active information systems, cleaning, maintaining, and repairing the pathways in the first place. And our duty of care as individuals, as passengers, and as people in the industry is warn passengers of hazards, properly train the personnel, have safety inspections, continue to update the design standards, and provide effective communications to everybody, both the employees, the passengers, the pedestrians, and the traveling public in general. And if I leave you with one word, and the most important word is safety. If we think safety, then we can do something to solve these problems, and we can make the railroad environment a safe place to travel with and to make it safe for our young people who are suffering from many injuries and fatalities as a result of their lack of understanding of the environment. Thank you.
Okay, great, Carl. We do have a couple questions here for you in conclusion. Why haven't railroad accidents involving pedestrians seen a major decline over the recent years?
Because they were declining, and they've been declining because the railroads and the government authorities have been making a concerted effort to address these issues. But we find that as time goes on, that we need more reinforcement, and there's this lack of reinforcement, and people are tending to be less observant. We have this effort of major enforcement, and we have this lax enforcement, and unfortunately, the lax enforcement, we start falling back into the same habits as we had before.
Okay, great. Here's another question. Why isn't there more application of intrusion detection devices? Like, why aren't intrusion detection devices used more commonly?
That's a good question. There's been a lot of research. We understand the equipment. There's a part of transportation which is called intelligent transportation systems that are working on collision avoidance between cars and trucks and cars. And in fact, I have a new Volvo, and I have collision avoidance systems. I have cameras on the side of my car which warns me if there's a vehicle on my blind side. There's also, if I'm backing up into a vehicle that's behind me, or if a vehicle is too close to me in front of me or making a sudden stop. This all exists for automobiles and is available for trains. In fact, there are inexpensive, most trains today, they're installing they have black boxes, and now are beginning to install video cameras which also record live time what is happening in the right-of-way. There's no reason why this can't be installed. If the federal government made it mandatory, we could see it happening overnight. It's not expensive, and it's not complicated to install.
Okay, great. In your opinion, can most pedestrian accidents be prevented?
If we are very diligent, yes. If we constantly reinforce the rules and regulations, we constantly provide the information, just about every accident could be, if we can make children aware of what danger they're taking upon themselves on entering the right-of-way and get their parents involved, because I've been involved in certain circumstances where I've interviewed the parents and they said, well, you know, they've been doing this for 70 years. Why should they stop now? You know, that's the kind of attitude. Protection and prevention starts at home for young people, and we're a little too permissive, and we don't provide enough enforcement, and we don't punish those who perform. The punishment is there isn't really no punishment for the young people.
Okay, great. I don't see any other questions in the queue, so I'm going to wrap it up here. I want to thank everybody for taking time out of their busy schedule. Oh, we do have a question here, Carl. I'm sorry. Linda asks, what is the railroad's rationale for the crossing configuration which puts barriers at motor vehicle crossings and no barriers at adjacent pedestrian crossings?
Well, they only do what's required. What they're doing meets the rules and regulations. We have to go beyond that, and we have to provide. In urban areas, we see gates for pedestrians. We see a lot more being done. We really need to push. The railroads need to be pushed into this area. They're only doing what they need to do because it's an expensive proposition. Railroad crossings, the ideal solution is eliminate the crossing by having a grade separation. That's extremely expensive. And the next step is there are various levels. I haven't shown you pictures of it. I'm saving it for the next presentation that we're going to be making in January, where we're going to be focusing on railroad crossings and motor vehicles. And in those cases, I'll show you pictures where the crossing, the only thing at the crossing is two pieces of wood that are nailed together on a post, and it says railroad crossing. I hope that answers the question.
Yeah. We have a question here from Rudwin, who asks, what duty would a train operator have if he sees a trespasser approaching a railway where no fence exists? Any difference if the pedestrian is on the other side of the fence in terms of slowing speed, emergency action?
Well, if there's somebody in the vicinity of the right-of-way, then they should be using their horn and bells to warn that individual. And train operators know where young people are crossing the tracks, because where there's a two-track system, they see the kids on the track on the other way, and they should really be slowing down. But if the track is a Class 4 track, then they can go at the speed that is allowed. But I think there's a question of being prudent. If you're going through an area where there's a lot of trespassing, I think even if the rules allow you to go faster, I think it's prudent on the part of the operator to operate at a slower speed so they can safely stop if a child should dart into the right-of-way.
Okay, great. I don't see any other questions in the queue, but if you do have a question for Carl that comes into your mind after we conclude the presentation, you can send me an email at mhyde@tasanet.com. My email is posted on the screen right now, and I will forward your question on to Carl, and I'm sure he'll do his best to get you the answer as quickly as he possibly can. If you'd like to speak to Carl about a case or project, you can contact us here at 800-523-2319. We will be sending out the link to the archive recording of this webinar tomorrow morning. The archive recording of this webinar, as well as the archive recordings of all the TASA webinars, are found in the TASA Knowledge Center. If you go to the homepage, www.tasanet.com, and click on the tab Knowledge Center, you'll see a link for webinars. Click on that link. You'll find all the archived webinars for attorneys. If you have any questions or comments, please email me at mhyde@tasanet.com. We do look forward to hearing from you, receiving your comments. It makes our presentations as good as they possibly can be, and we're always looking to improve them. Look for as Carl said, he will be doing another webinar in January. We have another webinar coming up on the 18th of November and 2 in the month of December. Please look in your inbox for an invitation from the TASA Group. I thank you again for taking time out of your busy schedule to spend with us. We look forward to seeing you at future events. Thank you so much, Carl, for your time as well. Your presentation was excellent.
Thank you very much.